Welcome everyone. So in this video I will be going through the solution to question 327 from the set of exam P-sample problems on the SOA website. Alright, so the question reads: individual burglary claim amounts covered by policies of an insurance company are normally distributed with mean 2,500 and standard deviation 500. The probability that the mean of a random sample of 100 claims will exceed k is 0.01. Calculate k. Alright, so I'm going to let x be the claim amount per policy, and of course that is normally distributed with mean 2,500 and the standard deviation of 500. Alright, but this information down here, I'm going to define a new random variable to represent the average of the 100 claims. I'm going to let that be A. So A is the average of a random sample of 100 claims, and the probability that A exceeds K is equal to 0.01, and I'm asked to calculate the value of K. Alright, so in order for me to calculate the value of K, I need to find the expected value of A and I need to find the variance of A. Now please bear in mind that A has a normal distribution. So remember what A is. A is just the average of a random sample of 100 independent and identically distributed random variables, and each of those variables is normally distributed. So therefore the average of 100 of them, denoted A, is going to also be normally distributed. Alright, so the expected value of A is equal to 2,500. So remember that whenever it is the case that we have independent and identically distributed random variables, I don't think the independence is relevant in this case, but whenever it is the case that we have identically distributed random variables and we want to find the average of a certain amount of them, the average of a certain amount of them is going to be the same as the average or the expected value for each of those variables. So that is the concept that I used here. Right, hope you're seeing that. And now I need to find the variance of A. So the variance of A, I'm going to use a little shortcut to do this. So the variance of A is simply 1 over 100 squared multiplied by 100. And what is the variance for each claim? The variance of each claim is 500 squared. Remember what we were given here is just the standard deviation, so the variance is just 500 squared. So 500 squared. And when this is plugged into the calculator, we will end up with 2,500. Now bear in mind that if it was the case that we got, let's say 200, let's say that A was defined as the average of 200 of these claims, of these identical claims. The variance of the average of A would be 1 over 100 squared, not 100, pardon me. It would be 1 over 200 squared, yes, 1 over 200 squared multiplied by 200 multiplied by 500 squared. If it was the case that A was defined as the average of 500 claims, 500 of these identically distributed claims, the variance of A in this case would be 1 over 500 squared multiplied by 500 multiplied by the variance of each of them, which is just 500 squared. Alright, so that is the concept that I used to work out the variance of A right here. Alright, so A is distributed normally. A is distributed normally with a mean of 2500 and a standard deviation of 2000, not standard deviation but rather variance of 2500. And we need to find out what the value of k is. What I'm going to do in this case, I'm not going to directly use what I was given here to find out what k is. I'm going to rather find the complement of the probability of A greater than k. And the complement of the probability of A greater than k, that is the probability that A is less than or equal to k is equal to 0.01. Alright, and the reason that I did this is because on the standard normal table, on the standard normal table, the z square values, they give you the cumulative probability up to that particular z value. Alright, so that is the whole reason I rearrange it to get this. And I should not even have 0.01 here, it should rather be 0.99. Pardon me for that, it should be 0.99. Alright, and one more thing I think I should have mentioned though, I should have mentioned this earlier, the fact that they say a random sample of 100 claims. Randomness implies independence. Alright, so that is how we know that the variables, the 100 variables, we have independence amongst them. Alright, and because we actually have independence amongst them, that is why we were able to use this technique in order to find the variance of x. Alright, so if we have independent and identical distributed random variables, we want to find the variance of the average of a certain amount of those independent identical distributed random variables. Let's say 200 of them. The variance would be 1 over 200 squared multiplied by 200 multiplied by 500 squared. If it is 300 of them, it would follow pretty much the same pattern. Alright, but remember that you must have independence and you must have identical distribution among the variables in order for that to work. Alright, yes. Okay, so let's figure out what k is. So I'm going to standardize this thing. So standardizing this is going to give me the k minus the expected value of A is 2500, and the standard deviation of A, that's the square root of 2500, that's simply going to give me 50. This is equal to 0.99. I'm going to check my standard normal table, and I'm going to see where I can find 0.99 here. See where I can find the probability of 0.99. Alright, so I think this gets close enough to 0.99, so I'm going to use this value. 0.99 is not on the table, but the closest I think I can get to it is this value. And the z square that corresponds to a probability of 0.99 is 2.3, right? So that is 2.3. So I'm going to say 2.33 rather, 2.33 is equal to k minus 2500 over 50. So that's k, alright, 2500. And solving for k, I'm going to end up with k is going to be equal to, you know that, yes, so k is 2616.5, and that corresponds to the value of That corresponds to, I should say, C. Alright? Close enough for the answer. Alright? Any questions, please?